Hello, this video is going to be looking at the question, is God needed for scientific laws? On the surface, it might seem that the answer is yes. You may be thinking that a law requires a lawgiver, and since we have scientific laws, there must be a lawgiver who has given us these laws. However, in the real world, whenever we have actual lawgivers, these are people who legislate prescriptive laws. Like the laws of a country tell us what we are allowed to do, what we're not allowed to do, and they impose penalties on us for doing certain things. Or the rules of a game say that we're not allowed to do certain things in a game, like in chess. We cannot move a knight in a straight line. This is against the rules of chess, but it's not physically impossible. Our prescriptive laws do not tell us what is physically impossible. They tell us what we're not allowed to do. They're prescribing what we should and shouldn't do. But scientific laws are a completely different animal than prescriptive laws. Scientific laws are descriptive. And what they describe are regularities in nature. And so all we need to have scientific laws are the regularities that underlie them. And here I want to distinguish between our conception of certain regularities in nature and those regularities themselves. What we may call a scientific law might not be fully accurate, because it might not accurately describe what regularities actually exist in nature, but still, it might describe, as best we can tell, those regularities. So sometimes our scientific laws are going to be approximations of the regularities in nature. But the regularities in nature are a real thing. And our what we call our scientific laws are our best attempt at describing these regularities. So bear that in mind. Okay, now let me flip the question to, in what kind of universe would we not have regularities? Well, one example that comes up are comic book universes. If you read comic books about the same characters over several years, you may notice various continuity errors, or various characters just disobeying the laws of physics. Well, in real life, we don't disobey the laws of physics, but violating the laws of physics, and which doesn't happen in real life. And this is possible because comic book stories are imaginative stories written by people who are not held to the rules of, who are not held to scientific law, who are not held to keeping everything consistent. They're written by different people who don't check with each other that everything fits together. So you often have comic book stories that do not fit together, and this is because they're fictional stories written by people. Now, if the universe were such that it was being manipulated behind the scenes by God, like if God was pulling the strings of the universe, then we could have various irregularities just due to the whim of God. But if we don't have that, then whatever happens in the universe is going to be due to the nature of what things are made of. So the regularities in the world are going to be due to what things are. Consider this. True chaos requires truly different materials that differ at the most basic level. This panel here is the one that took me the longest to make, and each word is made with a different font. In some words, chaos and level, each letter of the word is made with a different font. So this took careful attention to do, which is not what you would expect from chaos, but to have something like this in the world, to have things made of very different materials from each other that are all irreducibly different, this is the kind of thing you would need. And this kind of thing is something you might expect if you had a deity creating the universe. But if you don't have a deity creating the universe, then you might expect everything to be made of basically the same kind of stuff, and things that appear to be different would just be different arrangements of the different things in the world. And That's actually how the world is. At the top level here, we have countless molecules. There are so many molecules, we don't know how many there are. But all of these molecules are made up of elements. And as far as we know, there are only 118 known elements, and only 90 of those occur naturally, as far as we know. So the number of elements that these countless molecules are made of is a much smaller number. And likewise, these elements are made up of three basic subatomic particles: electrons, protons, and neutrons. And these are much smaller in number than the known elements. And then these subatomic particles are made up of quarks. And speaking of this more philosophically, we may say that everything reduces to what we may call matter. Everything is material. It's all be made of the same kind of material which we call matter. And so it's the properties of matter that are responsible for the properties of the various things that are made up of matter. But you may be thinking, well, we don't just have matter, we have all these different arrangements of matter. How could we go from simple matter to all these different complex arrangements of matter? And you might think, well, this has to be due to a designer playing around with matter and doing different things with it. Well, actually, there is a very simple axiom which accounts for this. I call this the axiom of stability. And it goes like this: ceteris paribus, which is Latin for other things being equal, more stable things last longer than less stable things. So in the universe, you may have all kinds of different arrangements of the same basic stuff, of matter. But some of these arrangements are going to be unstable, and those unstable ones will not last long. And then the stuff that they were made of will fall into other arrangements. But other arrangements will be stable, and the stable ones will last. So as things are falling into different arrangements, the stable ones last, the unstable ones don't last, and the material gets mixed up again into other arrangements, some of those which will become stable and last. So the stable arrangements of matter are going to last, and we get over time a gradual accumulation of stable arrangements of matter. Now, there only can be certain kinds of arrangements of matter that are actually stable. And so this limits what we find of stable objects. So, for example, we have protons and neutrons and electrons, which seem to be stable arrangements of matter. And then we have the hydrogen atom, which is a very stable arrangement of matter. A hydrogen atom can last for millennia. So we have lots of matter falling into different arrangements, but ultimately much of that matter falling into the arrangement of a hydrogen atom. And whether we have a hydrogen atom here or we have a hydrogen atom on the other side of the universe, if we can speak like that, we have something that's very similar to something else. Hydrogen atoms are going to be very similar to each other wherever they appear in the universe, and they're going to have similar properties, whether here or far, far away. And this is going to create regularities in the world. And now, once we have hydrogen atoms, these hydrogen atoms are going to fall into different arrangements, and some of these arrangements will be more stable than others. One of the most stable arrangements of a hydrogen atom is a star. Hydrogen atoms come together through the power of gravity, and they become so a collection of them becomes so massive that they start squeezing each other through the power of gravity, and because of this, they start to fuse hydrogen atoms together into elements with higher atomic numbers. So from hydrogen we go to helium, and then from helium to other atoms. And many of these arrangements of protons and electrons and neutrons are going to be very stable. Some may not be so stable, but generally we're going to have a greater collection of elements with lower atomic numbers and less elements with higher atomic numbers. Though there are a few elements with low atomic numbers that are just not as stable, and we don't have as many of those. But anyway, this process is caused by the axiom of stability, creates various new regularities in the world. And it creates new building blocks that things can be made of. The hydrogen atoms became a new building block. Then the materials they were made of became building blocks for elements with higher atomic numbers as they were compressed together for fusion. And these elements come together into different arrangements, which we call molecules. And then we can have minerals and other more complex arrangements of things. And this is all through the process of stable things sticking around and unstable things not sticking around because of the axiom of stability, rather than because of a creator planning all of this out. So it looks like we get regularities. We can get regularities without a lawgiver producing them. These regularities follow simply from the nature of how things are. This video has been based on an article I wrote for my blog last year by the same title. And you may notice here that the title of my blog has changed to reflect the title of this channel. I just recently acquired the domain fortheloveofwisdom.net, which I'm now using for my blog. The previous domain, wisdom.is-best.net, will still work, so old links are not broken. But this is the one to use when you want to go to the site now. And let me just page through this a little bit so you can read it just in case the blog ever goes away. You have been watching For the Love of Wisdom, my YouTube channel on free thought, philosophy, and critical thinking. If you've liked this video, you can favorite it or share it or like it down below. And if you want to see more videos like this, consider subscribing to For the Love of Wisdom. That's all one word, and there's a button for it in the top right here. And now let me draw your attention to some other videos I've made on related subjects to this one. A few years ago, I did a book review of Darwin's Dangerous Idea by Daniel Dennett. And much of this video is me talking about my ideas of how natural selection can account for order in the universe. And it covers some of the same ideas that I've covered in this video. And I've also made a video more recently called Would Aliens Look Like Us?, which looks at the question of if extraterrestrials are visiting Earth, would they resemble us or would they look, say, completely different from us? And I think there are good reasons because of parallel evolution why sentient aliens who could get off-world and come to visit us would actually resemble us in some ways.